We are Team 1, and this is a presentation of our final challenge for 6141, Robotics, Science, and Systems. Our challenge was to escape from a maze in under 6 minutes. The maze is multi-cursal, tight, completely unknown in advance, and not simply connected. It is bounded by a known radius relative to the starting location. Points were taken away for collisions and human intervention, but were given for every second under 6 minutes left after exiting. In order to escape the maze, our robot must move fast and randomly and be able to handle 3-point turns. Our robot used the Hokuyo UST-10LX sensor, which weighs 130 grams. It has a rotation rate of 40 Hz and a horizontal field of view of 270 degrees. Here, you can see our robot following the trajectory as fast as possible. For the final project, our technical approach to escaping the maze involved 3 steps. First, we implemented SLAM with Google Cartographer. Cartographer shows a robot simultaneously localizing itself and mapping its environment. Then, we created a Maze Explorer algorithm. The robot would alternate between following the left and right walls for a given amount of time, exploring the maze, and using a safety controller to prevent collisions. Then, it would stop and path plan a way out of the maze and follow the trajectory created by our RRT implementation. This cycle would repeat until the robot escapes the maze. Here, we can see our robot exploring its environment while it uses Cartographer to simultaneously localize itself and map its surroundings. In this video, you can see a robot alternate between following the left and right walls for a given amount of time. This was our first implementation of the Maze Explorer. As you can see, the safety controller needed some tuning to smoothen functionality. This required us to adjust parameters such as the minimum distance and the cone angle of the safety controller. This video shows the latest Maze Explorer after some tuning to smoothen out the safety controller. Notice our 3-point turn at the end.
I would like to reach out my hand, tell you to run. Well, pick me up with golden hand. Tell you to run.
Here we show the results of our RRT implementation running in simulation. RRT, or Rapidly Exploring Random Tree, works by growing a search tree in the direction of the goal point using iterative random sampling and feasible trajectory generation. If we specify a start and goal point in RViz, we can see RRT plan a path, shown in blue, between the 2 points. As RRT runs, we can see the sampled points in each iteration of RRT represented with blue arrows, and at the conclusion of planning, we can also visualize the search tree, shown in red. If RRT cannot find a path within a specified number of iterations, then it returns a path from the last explored node in the tree to the start point. During testing, we ran into complications with the path planning and found that the Maze Explorer alone was sufficient to exit the maze. The downside of removing the path planning is that we are essentially using a non-deterministic random mouse algorithm. Therefore, the time it takes to solve the maze varies. Here you can see Cartographer map out the robot's environment. Our robot escaped! During the final challenge, we implemented our Maze Explorer and successfully exited the maze in about 2 minutes of the 6 we were given to escape. We required some tuning of the time spent following each of the walls to get the robot to successfully escape. You can see our robot explore the maze by alternating between following the left and right walls for a given amount of time. Our tuned safety controller prevents collisions.